Today we are going to work on multiplying binomials and polynomials as in a step forward from that. Binomials, two terms. So we're going to multiply two terms, a two-term polynomial times a two-term polynomial. There are two basic methods to do this. The first one, FOIL. I like FOIL. FOIL works well. Okay. Multiply the first terms. That's the first term in each group. The outside terms, the two terms that are on the far outside. The inside terms, the two that are on the inside. And then the last terms that are in there. You multiply them like that, then you combine up any like terms that there are. And usually there are like terms. You guys shouldn't have any that don't have like terms in them. Okay, that's what the FOIL method is. First, outside, inside, last. As an example, first terms, x times x. Those are my first terms. X times x gives me x squared. Okay, after the first term, the first term in each group. Outer, the two terms on the outside all together. X times 5 gives me 5x. First, outside, inner terms. Those are these two terms in here. 2 times x, 2x. And then the last terms. The last term in each one, L. F-O-I-L. First, outside, inside, last. 2 times 5 gives me 10. So I have multiplied everything there is. This is also called distributing. There's another way of doing that. Distributing is a slightly different method for this. I hate that. I like FOIL. I really like it. But FOIL only works if you have two terms. We're going to cover another way if you have more than that. I'm not done with this, though. All I've done is all my multiplication. What I still have to do is combine up like terms. And usually, 90% of the time, your like terms are those two right there. Everything else is not a like term. So my final answer would be x squared for the x squared. And then I combine up these two like terms there to get 7x. And then I have my last term here. Plus 10. A little bit of foreshadowing. We are going to be working soonish, I think next week, going the other direction. We're going to go from x squared plus 7x plus 10 to get x plus 2 times x plus 5. The better you are at multiplying this way, the better you're going to be at factoring going the other way. Okay? You want to try to work really hard to make this go as smooth as possible. The better you are, if you start to see patterns, start to see things, the easier it's going to be to go the other direction. I have some tricks to help, but it is one of the more difficult things that you will do, but it's also one of the more important things you will do. And there's a few big things in Algebra 1. This stuff we're doing here and the stuff we're going to do next week is probably one of the biggest. Okay. Now, the other method is the box method. Yeah. The other method is the box method. I like this one too. And if I do anything other than two binomials, I always use a box. Box method is easy. What's the first thing I'm multiplying? X plus 2. I pick a side. It doesn't matter which side, whether it's the top or the front. I pick either one of them and I put x plus 2. X and 2. Like two things I'm multiplying in the first binomial. And then the other one, x plus 5. I put x, I put 5. You see where the x and the 2 and the x and the 5 come from. Okay, do you see that? That's an important step. Fill it in like a multiplication chart. How does a multiplication chart work? You take this times this and you put it in the box, right? X times X gives me X squared. X times 2, 2X in that box. Hmm? No. What? No. But it's very close to it, though, actually. Okay. I know what that is. It's genetics, to be more specific. Okay. And then I have, for this box here, I have 5 times X to get 5X. And then 5 times 2 to give me 10. So I did the same thing. If you look, I get the same thing that I did when foiling. X squared, 5X, 2X, and 10. X squared, 5X, 2X, and 10. The same terms. Either way, 2 methods of doing the same thing. Now, one of the things I like about the box method is your like terms are on a diagonal. So when I write my final answer, any like terms I have will be on a diagonal. I have X squared, and then I have 2X plus 5X gives me 7X, and then I have plus 10. Okay. 2 different ways of doing the same thing. I like FOIL a lot. Okay, if I have 2 binomials, 2 terms multiplying, FOIL works great. The thing about the box method is, if I have something other than 2 and 2, the box method works. I have, in my past, multiplied, 3-term polynomial times a 4-term polynomial. The only way to do something like that, keep your work organized, is set up a box. I like the box method because it organizes your work. Yes, what's your question?
I was going to ask where there's 7.
5 and 2. You see that? And then, like I said, the diagonals here is where your like terms will always be. They're going diagonally across. Okay? So that's where your like terms, combine them up, get to 7. Does that make sense? Okay. I think that's it for the first page. Okay, here's what I want you to do. These 3 problems. FOIL the first one, using the distributive property that I FOIL. That's what you do on the first one, FOIL. And then set up boxes for these 2. Okay? So on this first one here, FOIL. And these ones here, set up your box. Okay? So do those 3 problems. Okay, so let's go ahead and do these. So FOIL method, first, 2x times 3x gives me 6x squared. 2x times -7, -14x. 4 times 3x gives me 12x. 4 times -7, -28. Now that's just FOILing out. First 2 terms, 2x times 3x. 2 times 3 is 6. X times x gives me x squared. 2x times -7. 2 times -7 is 14 with the x on there. 4 times 3 is 12 with an x. 4 times -7, -28. Now I need to simplify, which means I combine up like terms, and my like terms are in the middle. Okay, so I have 6x squared. And then I have -14 and +12. Lucas. Gives me -2x. And then I have -28. And that's my final answer on that one. Okay? Now, box method. So I have x and -3, 4x, and -5. And it doesn't matter. You didn't have to put them on the same 2 sides that I did. As long as one side has one and one side has the other, it doesn't matter which one's which. Okay. 4x times x, 4x squared. X times -5, -5x. -3 times 4x. -3 times 4, that's -12 with an x. Negative 3 times negative 5 gives me positive 15. Okay, so that's just multiplying them. Combine up like terms. Where are my like terms at on this? My like terms are on the diagonal here. So I have 4x squared, and then I have negative 12 and negative 5 combined to give me negative 17. And then I have plus 15. 15, 1, 5, not just 5. Okay. I like the boxes, keeps it organized on the diagonal in particular. Okay. Same thing on this one here. Set up a box. 2 by 2, n minus 6, n minus 6, 4n, and 7. Once again, if you put your 2 on the opposite sides, the only thing that will be different are the 2 diagonals, but you'll still get the same answer in the end. 4n times n, 4n squared. 4n times negative 6. 6 times 4 is 24, so that's negative 24n. 7 times n, 7n. 7 times negative 6, that's negative 42. 7 times 6 is 42. And then once again, where are my like terms? My like terms are on the diagonal. So 4n squared, 7 and negative 24. Negative 17. Negative 17n, and then minus 42. Any questions on these? This is really important to do. It's simple, but it's really important to be able to do it. The better you are at this, the better and easier next week's going to be. And next week's one of the harder things we will do in here. Okay? Now, the last problem, and this is the one that's just like what you're going to do on your skills test in a minute. Multiplying a 2 by 3. I can't FOIL, because to FOIL, you only can have 2 terms and 2 terms. I have 2 ways of doing this. The first way, do not do it this way. This is not what I recommend, but often you will see this in textbooks, and some teachers really like it. I hate it, but it does work. I've done it myself. Is you distribute, which means I do 2x times 3x squared, 2x times x, 2x times negative 5, and then I do the same thing with the second term. I don't like that. I don't do that. Here's what I do. I make a box. My box is not going to be a 2 by 2 box. My box is going to be a 2 by 3 box.
Oh my gosh, really? Wow.
2 by 3 box. 2x minus 7, 3x squared, x, negative 5. And then I fill in the box like I did the other box. You just multiply, filling in the blanks. 2x times 3x squared. So 2 times 3 gives me 6. X times x squared is x cubed. 2x times x is 2x times x, x squared. 2x times negative 5, 2 times negative 5 is negative 10 with an x on there. You just multiply across. Fill in the box the same way you did the 2 by 2 box. Same thing on the next level down. Negative 7 times 3x squared. Negative 7 times 3 is negative 21, and then I have x squared. Negative 7 times x, that's easy, negative 7x. Negative 7 times negative 5 is 35. I've multiplied everything. And here's the cool thing on this one. Where are my like terms? My like terms are on the diagonals. Those 2 are like terms. Those 2 are like terms. Every time, it's the like terms are on the diagonal. So I have 6x cubed 2x squared, negative 21x squared. Negative 21 plus 2 gives me negative 19. So I have negative 19 x squared. Negative 10x, negative 7x, negative 10 and negative 7 give me negative 17. So I have negative 17x. And then I have my 35 at the end. I have done this with really big polynomials before. And I use a box when I do it. Why? Because even if I have really big polynomials, my like terms are always on the diagonal. It's a great way to keep things organized. The hardest part about when you start multiplying big things like this is keeping your work organized. This does it better than anything I've ever seen. Okay? Any questions on this? Okay.